Our objectives in this lesson are the following. Number 1, define statistical concepts related to tests concerning means. Number 2, identify the appropriate test statistic when letter A, population variance or standard deviation is known. Letter B, population variance or standard deviation is unknown. And letter C, CLT is to be used. And number 3, apply the concepts of test statistic on real-life problems. Let's have a quick activity. Match the parameter and statistic to its corresponding symbol. First one, population variance. The symbol of this is sigma squared. Next one, sample variance. The symbol of this is S squared. Next, we have population mean. We have mu. Sample mean, we have X bar. Next one, population standard deviation, we have sigma. Sample standard deviation, we have small letter S. Population size, we have capital N. And sample size is small letter n. Let us define some terms. First one, population. It is the totality of elements under investigation, while sample is the subset of a population. Population size, denoted by capital N, is the total number of elements in the population, while sample size, denoted by small letter n, is the total number of elements in the sample. Population mean, denoted by mu, is the mean of all values in the population, while sample mean, denoted by X bar, is the mean of all the values in the sample. Let's continue. We have the population standard deviation, denoted by sigma. It is a parameter, a measure of variability that is calculated from the population. Sample standard deviation, denoted by small letter s, is a statistic. It is a measure of variability that is calculated from the sample. Population variance, denoted by sigma squared, a parameter, a variance that is calculated from the population data. If you have the variance, take the square root of it, you now have the standard deviation. Same thing is true with sample variance, denoted by S squared. When you take the square root of this, you now have the sample standard deviation. Sample variance is a statistic. It is a variance calculated from the sample data. I did not give any more technical definition of these four because our objective is not to compute them but to define them to help us in identifying the appropriate test statistic to be used. I have created here a detailed guide on how to decide whether to use z-test or t-test. There are three questions that you have to answer. First, is the distribution normal? Second, is the sample size greater than or equal to 30? And third, is the population standard deviation known? Let me explain this. If you are given a situation, look first if the distribution is normal. If the answer is yes, proceed to the next question. Is the sample size greater than or equal to 30? If the answer is yes, continue with the third question. Is the population standard deviation known? If it is given, then you are going to use z-test. If the answer to the third question is no, still you are going to use z-test, but since the population standard deviation is unknown, you are going to use sample standard deviation instead. Another possible condition is the distribution is normal, but the sample size is less than 30. Proceed to the next question. Is the population standard deviation known? If it is yes, still use z-test. If the answer is no, then this time you're going to use t-test. Let us go back to our first question. If nothing is mentioned or the distribution is not normal, look for the sample size. Is it sufficiently large? When we say sufficiently large, the sample size is greater than or equal to 30. If the answer is yes, then look for the population standard deviation. If it is given, then use z-test. If the population standard deviation is unknown, Then we are going to apply the CLT, Central Limit Theorem. CLT states that if the sample is sufficiently large, then the distribution of the sample means will be approximately normally distributed. Hence, we are going to use z-test. But just like here, since the population standard deviation is unknown, then we are going to use sample standard deviation. Now, how if the distribution is not normal and the sample size is less than 30? Then you can neither use z-test or t-test. So what are we going to use then? We are going to use non-parametric test, which we are going to discuss some other time. For the meantime, we are going to choose between z-test or t-test. Let me emphasize that both z-test and t-test assume normal distribution. So if the topic is identifying appropriate test statistic and the only options are z-test or t-test, then it is assumed that the distribution is normal. So sometimes it is not stated in the problem that the distribution is normal because it is already assumed. Again, because both z-test and t-test assume normal distribution. In that case, you may proceed to the second question, which is about the sample size, and then followed by if the population standard deviation is known. The bottom line here is that if the population standard deviation is known, then you are going to use z-test. If sample standard deviation is given instead of the population standard deviation, but the sample size is greater than or equal to 30, still you are going to use z-test. You will use t-test if the population standard deviation is unknown and the sample size is less than 30. I made the table here if this will help you better in deciding whether z-test or t-test. We use z-test if the distribution is normally distributed, our sample size is greater than or equal to 30, and we know the population is standard deviation. We use t-test if the distribution is normally distributed or approximately normal, our sample size is less than 30, we do not know the population standard deviation, but the sample standard deviation is given. And we apply CLT, Central Limit Theorem, if we do not know if the distribution is normally distributed or not. But we have sufficiently large sample size, meaning n is greater than or equal to 30. And the sample standard deviation is given. Try this, z-test or t-test. Number one, it is always used for normal distribution. The answer is z-test. Number two, appropriate test statistic for normal population with sample size less than 30 and known sample standard deviation. Answer here is t-test. Number three, based on central limit theorem, this is the test statistic to be used when the sample size is sufficiently large. This is z-test. Number four, appropriate test statistic if the sigma is unknown. We use t-test. Number five, appropriate test statistic if the variance is known. Here we use z-test. Let us do extra challenge. Look on what information can be derived from the given situation and decide on what test statistic must be used. Some of my examples are hypothetical because in real life, we seldom know the values of the parameters like population standard deviation, especially if our population is huge like the fishes in the ocean or teenagers in a region or country. Let's have the first one. The average IQ score is 100 with a standard deviation of 15. 100 students were randomly selected and they have a mean IQ score of 97. Let me share with you my technique. The first thing that I look for is the sample size. followed by anything that pertains to the sample. Then, the rest is for the population. So here it says 100 students were randomly selected. So it means this is my sample size. N is equal to 100. And they have a mean IQ score of 97. This 97 is the mean of 100 students, meaning since 100 students is my sample, this 97 is my sample mean. So x bar is equal to 97. It follows that this average IQ score, which is 100, is the population mean denoted by mu. With a standard deviation of 15, this is the standard deviation of the population. So this is sigma. Sigma is equal to 15. Now, let us analyze. Is there anything mentioned about the distribution? Is it normally distributed? Nothing is mentioned in our problem here. So from question number 1, we'll move here, no or I don't know. Second question, is the sample size sufficiently large? Our sample is 100. It is greater than 30. So the answer is yes. Is sigma known? Do we have sigma? Yes, we do. So the answer is also yes. Therefore, we are going to use z-test. A while ago, I mentioned that if the topic is identifying appropriate test statistic and the only choices are z-test or t-test, then it is assumed that the distribution is normal. So let us say we assume that the distribution is normal. So we'll proceed here. So this is yes. We have a sample size greater than 30, so we have yes. The population standard deviation is known, so we have yes. Therefore, is still, we are going to use z-test. Number 2, assuming normality. 35 students were randomly selected to test their typing skills. They have a mean of 38 words per minute. Let alpha be equal to 0.05. Test if this is significantly different from the average typing speed of 40 words per minute with a standard deviation of 3 words. So again, let me look first for the sample size. It says here 35 students were randomly selected. So this is my sample. N is equal to 35. They have a mean of 38 words per minute. So this mean of 38 is mean of the sample. So sample mean x bar is equal to 38. And then I am also given here the level of significance. Alpha is equal to 0.05. So it follows that this average typing speed of 40 is the population mean because I already have here the sample mean. So this is population mean mu. And this standard deviation is the standard deviation of the population. So this 3 is the sigma. Let us analyze. So it says here, assuming normality. So the answer to the first question is yes. Now let us look at our sample size and it is 35. So that is greater than 30. So the answer again is yes. Let us look if sigma is given. And yes, we have sigma here. Sigma is given. Therefore, again, we are going to use z-test. The difference of this problem from the first one is that in the first one, it is not really stated that the distribution is normal. So we proceed first in this side. But we also tried on this side when we assume that the distribution is normal and we arrive at the same answer. Next example, the mean weight of grade 2 students in Bright School is 30 kilos. The mean weight of 50 students is 30 kilos with a standard deviation of 1.7 kilos. So let me look first for the sample size. It says here, the mean weight of 50 students, only 50. While this one is the mean weight of grade 2 students, meaning all grade 2 students in Bright School. So the sample size is the 50. So N is equal to 50. And their mean weight is 30 kilos. So sample mean is equal to 30. With a standard deviation of 1.7 kilos, this 1.7 is the standard deviation of 50 students, which is my sample. So this is sample is standard deviation, denoted by a small letter s. So it follows that this 30 kilos, which is the mean weight, is the mean of the population. So mu is equal to 30. Let us analyze. Nothing is mentioned about the distribution, so we do not know if it is normally distributed. Let us proceed to the next question. Our sample size is 50, so that is greater than 30, so the answer here is yes. Let us look for sigma. Do we have sigma here? No, we have here small letter s, sample standard deviation. So the answer here is no. So in this case, we are going to apply central limit theorem, meaning we are going to use z-test, but instead of sigma, we are going to use sample standard deviation s. Now, what if I assume that the distribution is normal? Because I only have z-test or t-test and both of them assume normal distribution. So let us take this path. The answer is yes. Our sample size again is greater than 30, so the answer is yes. The population standard deviation is not given, so the answer is no. So still, we are going to use z-test, but we are going to use s instead of sigma. So same answer. Number 4, suppose a delivery company claims they deliver their packages in 2 days on average, and you suspect it's longer than that. To test this claim, you take a random sample of 11 packages and record their delivery times. You find the sample mean is 2.3 days and the sample standard deviation is 0.35 days. Assume a normal distribution. So first again, let me look for the sample size. You take a random sample of 11 packages. So the sample size is 11. It's already stated here, sample mean. So 2.3 is the X bar. Next, we have here sample is standard deviation. So this will be a small letter s, 0.35. So it follows that this 2 days on average is the population mean. Mu is equal to 2. Let us analyze. So assume a normal distribution. So the answer to the first question is yes. And then our sample size, is it greater than or equal to 30? We only have 11. So the answer is no. Is the population standard deviation sigma given? No, what we have here is sample standard deviation. So the answer to this question is no. In this case, we are going to use t-test. Next one. In the past, it took an average of 30 minutes queuing in the registrar's office. The dean introduced a new procedure, and he believes that it is effective. A sample of 200 students from a normally distributed distribution revealed an average of 24 minutes waiting time, with a standard deviation of 7 minutes. Test the claim at 10% level of significance. So first, what is our sample size? A sample of 200. So N is equal to 200. Revealed an average of 24 minutes waiting time. So this is the sample mean X bar with a standard deviation of 7 minutes. This is the standard deviation of 200 students, which is the sample. So this is the sample standard deviation. S is equal to 7. So it follows that this average of 30 minutes is the population mean. So we have mu is equal to 30. And I also have here 10% level of significance. Alpha is equal to 0.10. Though this is not necessary in identifying the appropriate test statistic, we are going to use this in the actual hypothesis testing. Now, let us analyze. So, we have here normally distributed distribution. So, the answer to the first question is yes. Let us look at our sample size, and we have 200, meaning that is greater than 30. So, the answer is also yes. Now, is the population standard deviation known? Do we have sigma? We don't have. What we have here is sample standard deviation. So, the answer here is no. So meaning we are still going to use z-test, but instead of sigma, we are going to use a small letter s. The sample is standard deviation. Last one. A milk tea shop claims that the mean time to fix an order is 3 minutes with a standard deviation of 0.5 minutes. 23 customers were randomly selected and revealed that the mean time for their order was 3.5 minutes. Assuming normality, test with 0.05 level of significance if there is enough evidence for a counterclaim. So let me look first for the sample size. 23 customers were randomly selected. So this is my sample size. N is equal to 23. And revealed that their mean time for their order was 3.5 minutes. So this 3.5 is the sample mean, X bar. Next, we have here the level of significance, 0.05. So it follows that this 3 minutes here is the population mean. So this is my mu. Mu is equal to 3. And this is standard deviation of 0.5 is the standard deviation of the population. So this is sigma. Sigma is equal to 0.5. Now let us analyze. So it says here, assuming normality. So the answer to the first question is yes. Let us look for our sample size. We only have 23, so it is less than 30. So the answer is no. Now, is sigma given? Yes, we have here the sigma. Sigma is known. Therefore, we are going to use z-test. For the summary, here are the things that we discussed. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. The plant manager believes that the operators take a lunch break for more than 60 minutes. A sample of 15 operators from a normal population were randomly selected, and it was found out that their mean lunch break is 60 minutes with a standard deviation of 5 minutes. At 0.05 level of significance, is the mean lunch break greater than 60 minutes? So let us determine first our sample size, a sample of 15 operators. So our N is equal to 15. It was found out that their mean lunch break is 60 minutes. So this is my sample mean. X bar is equal to 60 with a standard deviation of 5 minutes. This is the standard deviation of the sample. So this is a small letter S. Is the mean lunch break greater than 60 minutes? So this 60 will be our population mean. I also have here 0.05 level of significance. Alpha is equal to 0.05. Let us analyze. So it says here from a normal population. So the answer to the first question is yes. Our sample size, we only have 15. So the answer to the second question is no. Is sigma given? No. What we have here is small letter s. So the answer here is no. Therefore, we are going to use t-test. Gets? Our next lesson is identifying appropriate rejection region for a given level of significance.